All right, so here we have formula from section 7.3, which was mainly focusing on double angle formula, half angle formula, which are related to the angle reduction. So we have sine of 2x minus cosine of 2x is supposed to be equal to the square root of 2 sine of 2x plus a pi. All right. So let's see, I definitely see double angle here and here. So that's an option. And it's a good idea to have a collection of trig identities nearby for the rest of the quarter. And so here I have pulled up, Clark University has a nice page of trig functions. Wikipedia has a great one too, but it has too many. It's kind of overwhelming. This has what they believe are the important ones, and I agree with them. All right, so like here, the sine double angle, cosine double angle. So it could be, we might use some of those here. And then other thing I noticed in that problem is they had a sine of the sum of two angles. So it could be that formula we need. And the question is, which is the right formula? Well, the right formula is the one that works. And you never know what works till you try something. I'm leaning toward the angle sum formula on this one. We could try it both ways. So I'm going to think about this in terms of the sine angle sum. And that says the sine of the sum of two angles, let's call them alpha and beta, is equal to the sine of alpha cosine of beta, plus here means plus there, and then switch cosine alpha sine beta. Now here they also have a square root of 2 out front, so that means I'd need to put a square root of 2 in front of each of these. And then they're calling the alpha 2x and the beta a pi. So I'm just comparing a formula I recognize to what I have here. So square root of 2 sine of 2x plus a pi. And then I'm just going to replace the alpha and the beta over here too. Let's see if this helps. And so with these trig identities, don't get stuck in option paralysis. Find an identity that looks like something in your problem and try it and see what happens. If it's a dead end, it's a dead end. Try a different one. 2x for alpha, a pi for beta. Square root of 2 cosine alpha is 2x. And sine is beta a pi. Okay. And we need to figure out what a is. So square root of 2 is in every single part. So oh wait, I'm not done comparing. I need to compare to this over here on that side. Well, then the square root of 2 is in every part, so I'm going to get rid of that first. So dividing everything by the square root of 2, I just need to think about the sine. Nope, I'm not ready for that. Premature. This right here is equal to that. It's also equal to sine of 2x minus cosine of 2x. So sine of 2x minus cosine of 2x. All right, and so this is kind of like problems we did back in 7.2. I have a sine of 2x here and a sine of 2x there. I have a cosine of 2x here and a cosine of 2x here. And otherwise, what I'm going to do is I'm just going to consider this is 1 times the sine, and this would be -1 times the cosine. So this 2 cosine of a pi has to be 1. And this square root of 2 sine of a pi, that has to be -1. Let's see how that works out. So square root of 2 cosine of a pi has to equal 1. So that means the cosine of a pi has to be 1 over the square root of 2, which looks familiar, right? If we multiply top and bottom by the square root of 2, that's the square root of 2 over 2. Thinking about the unit circle here, Square root of 2 over 2 happens at pi over 4 for cosine. So I think this angle right here is supposed to be pi over 4. So a pi is the same as pi over 4. Divide the pi's out, and I get a is supposed to be 1/4. And they claim a should be some number between 0 and 2. All right, let's double check with this part over here to see if that is also in agreement. This over here said, let's see, the square root of 2 times the sine of a pi should be -1 if I want these two things to match up. Should be equal to -1, excuse me. Divide the square root of 2 over sine of a pi has to be -1 over the square root of 2, which is negative square root of 2 over 2. Think about that in the unit circle. Sine is a y value. So y equals negative square root of 2 is over here somewhere. That would be related to the negative pi over 4, right? So that one thinks that a pi is negative pi over 4, which means a could also be -1/4, but I want a to be positive. Yeah, so it's got to be this one right here, 1/4. How can I check? Graph it. Let's see if I replace a with a 1/4 here. Does this graph match that graph? So let's check our grapher. And let's just get a new one. Oops. So sine of 2x minus cosine of 2x. And the claim is that ought to be the same graph as square root of 2 sine of 2x plus, we think a is 1/4. So square root of 2 times the sine of 2x plus pi over 4, or 1/4 pi. Ooh, I didn't get it right. All right, so the other option was that a was a minus. Okay, that one works. All right, so I guessed wrong. Look at my notes. So this one didn't work, either because I made a mistake or something else. I don't see an error here yet. This one does work, but the value of a isn't positive. They wanted a positive version for a, so that's okay. So think about the a pi for a second. That's just a shift. All right, so a pi is really -1/4 pi, which is negative pi over 4. The alternative to that shift, let's think about that on the unit circle. Negative pi over 4 is down here. I want the positive version of that, which would be this right here. So that's going to be 2 pi plus that negative pi over 4. So 2 pi would be 8 pi over 4 minus 1 pi over 4. So that angle should be 7 pi over 4. Is that number less than 2? That does not look right either. Oh, but a would be 7/4, which is less than 2. Okay, that's got to be it. Let's test it. So instead of the minus, which worked, I claim a plus 7 pi over 4 should do the same thing. Okay, so a is 7/4 there. Now, I happen to think I should apply that formula. The other option here is to apply the double angle to these here. And so we have a bunch of versions for the double angle. Let's try it a different way, see what happens. So double angles are these right here. Interesting. I don't know if that makes our life any better, but let's try it. So I'm going to take this into a new screen, see if another routine is better. Your first try is not necessarily the easiest one, but you never know what the easiest one is until you try something else. Okay, so rethinking about this, what if we applied the sine of 2x double angle, which says twice sine of x cosine of x. So we could use that here. And then the cosine double angle, there's 3 different versions of that one. I have no idea which one would be better, but it says cosine squared of x minus sine squared of x is the first one. I'm leaning toward that one, sine squared. That looks like it's going to make this worse. All right, let's try it. So then, yeah, I'm not liking this. I'll show you why. If I rewrite sine of 2x, then I get twice sine of x cosine of x plus, no, minus. All right, so the minus means I'm subtracting both of these. So that's going to give me a minus cosine squared of x, and then minus a negative would be a plus sine squared of x. And that's supposed to be equal to the square root of 2 sine of 2x plus a pi. Eek. But again, looking at my first step here, it doesn't look too much worse than that. Maybe this will go somewhere, you never know. Since the sine squared is positive, I'm going to write that first. Sometimes changing the order might trigger something in my brain that will help solve it. Plus 2 sine of x cosine of x minus cosine squared. And I'm reordering it like this because I'm kind of thinking about a quadratic equation here maybe. Okay, what don't I like about this? I don't like the squares. I don't like that these are x's and there's a 2x over here. Mixing up periods as often makes things more difficult. All right. Pythagorean identity wouldn't help here because that's a minus. If I think about this like as a quadratic formula, this is something like you could say s squared plus 2sc minus c squared. And I don't think that factors, and even if it did, how would that help? See if that factored, what would it look like? It would be s times s, c times c. That's a negative, so these would have to be a plus and a minus. And if you multiply that out, that gives you s squared. The middle terms disappear, minus c squared, which doesn't match that. This is not factorable. This looks like a dead end to me. Dead end. Okay, so that happens. So again, my first instinct was to do the double angle, but I went with my second instinct was the angle sum formula, which I saw here, and the angle sum was productive, even though it took a couple tries. In the double angle formula, I don't see it. I don't see how this is going to resolve in any useful way. We might say combine this with the angle sum, then we'd be combining that right there with this up here, and that looks 10 times worse. All right, I'm pretty sure that this is a dead end, and we found one way to solve it that worked. Call it good.